We'll look a little bit more at radicals in this section, and this is where what we did in 11.3 will help us quite a bit. In this problem, we want to take the square root of 7 times the square root of 5. Well, 7 is a prime number. It can't be broken down any further, so we can't do anything with it on its own. And the same with the 5. It's also a prime number. We can't break it down. So what this is also telling us is that we can put these together both underneath the radical. Because they're both under square roots, we can put them together. It's a little bit like the opposite of saying when we have a fraction inside that we can just take the square root of the top and the bottom separately. If we have multiplication separately, we can put them together. And so this is really just the square root of 35. We can't do anything more with that because 35 is just 7 times 5. Which can't be broken down. So let's look at this one. Let's look at this 28. And let's break it down into prime factors. It's even, so we can divide by 2 and we get 14. 14's even, so we can divide by 2 and we get 7. So this is really the square root of 2 times 2 times 7. Now, since the first section of this module, 11.1, we've been saying square root. That's because we are understanding there to be sort of an invisible 2 there. It's really saying, when we say square root, we're saying we're looking for groups of 2. So this is a group of 2. That will come out as a single 2. Now this 7 doesn't have any other 7s to go with it, so it's stuck inside. So we would just write that 7 underneath the root. And this is our answer. We have 2 root 7, or 2 square root 7. Let's look at that 24. We'll break it down. So 2 goes into 24 with 12 times. 12 is even, so I'll divide by 2 and I get 6. 6 is even, so I'll divide by 2 and I'll get 3. So now I have 7 times the cube root of 2 times 2 times 2 times 3. Now remember that this 3 tells me that I'm looking for groups of 3. And here's a group of 3, so that's going to come outside. That will leave me with 7 times 2 times, this 3 doesn't have a group of 3, so it's just stuck inside the cube root. We didn't talk about it this time, but that 7 smashed against it, that means multiplication. So we just take this 7 times this 2, the things that are outside get multiplied together. The things that are inside have to stay inside, or like in example 1, the things that are inside get multiplied together. And that's our final answer. Let's look at 77. This is odd. This is an odd number, so we can't divide by 2. But I see that it has a 7, so I can do 77 divided by 7, which is 11. And 11 is a prime number, so I can't break it down. So this is really 7 times 11. And neither one of those has a group of 4, so I can't do anything with that. And I just end up with exactly how I started with. This is already simplified. Okay, so in this problem we need to deal with the square root of 50 first. So this is even. I can divide by 2 and I get 25. 25 ends in a 5, so I could divide by 5 and I get 5. So if I look at this, I'd have 15 minus 2 times 5 times 5. That's over 5. So again, if you don't see a number here, it's really a 2. It's saying I'm looking for things with a group of 2. It's a square root. So this 5 will come out, and that leaves me with 5. And this 2 is stuck inside because it doesn't have a group of 2. And that's still all over 5. Now this 5 on the bottom means that everything has to be divided by 5. So it really means I'm doing 15 divided by 5 minus 5 square root of 2 divided by 5. And 15 divided by 5 is 3. And over here, this 5 is outside, this 5 is outside. They can cancel each other out. And it leaves me with just the square root of 2. This is the same idea. Let's look at 18 first. I can divide by 2, and that gives me 9. And then 3 I can divide by, and gives me a 3. So I have negative 2 plus the square root of 2 times 3 over 3. And this is a group of 2, and that's what we're looking for when there's no number there. So that's going to come out, and leaves me with 2 plus 3 square root of 2 over 3. And this 3 in the bottom really has to go to both pieces, so that would be negative 2 over 3 plus 3 square root of 2 over 3. These cancel out and leave me with negative 2 thirds plus the square root of 2. Let's look at 63. 63 is odd, so I'm going to try dividing by 3 first, and that gives me 21. I'll divide by 3 again, and that gives me 7. And 7 is prime, so I know I'm done. So this is 3 times 7. And that y to the 4th really means that I have 4 y's here as well. Now there's an understood 2 here, so I'm looking for groups of 2. So here's a group of 2. That will come out as just a 3. Here's a group of 2. That will come out as a y. And here's a group of 2. And that will come out as a y. And I'm left with this 7 stuck inside. So I can put these together, and I end up with 3y squared square root of 7. So let's start by looking at this problem with this 135. It ends in 5, so I'm going to divide by 5 first, and that gives me 27. 27 can be divided by 3, which is 9, and 9 can be divided by 3, which is 3. So I have the cube root of, and I'll write these in number order, so 3 times 3 times 3 times 5. And then I'd have 6 x's and 10 y's. Two, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So this says I'm looking for groups of 3. So I want to see anything with a group of 3. So here's a group of 3. That will be a 3. Here's a group of 3. That will be an x. Here's a group of 3. That will be another x. Here's a group of 3. That will be a y. Here's a group of 3. That will be another y. And here's a group of 3, that will be another y. And then the things that aren't circled are stuck inside. So I have a 5 stuck inside, and I have a y stuck inside. So the things outside get multiplied together. 3x squared y cubed. And then the things that are inside get multiplied together. Don't forget to write this cubed here. That will count it wrong if that's not there. Let's look at 81. So divide by 3, it's odd. It's a good place to start. We get 27. Divide by 3, we get 9. Divide by 3, and we get 3. So we have the 4th root of 3 times 3 times 3 times 3. And a is there 5 times. And b is there 9 times. This tells me I'm looking for groups of 4. So here's a group of 4. Here's a group of 4. Here's a group of 4. And here's a group of 4. I'd put the fourth root of what's left. There's an a left, and there's a b left. So we get 3ab squared, fourth root of ab.